In chemistry, we do a lot of measuring, and you'll be doing, a few labs where you have to measure and read scales on devices, things like triple beam balances and graduated cylinders. And while some of these things are moving to digital devices, like a digital scale where it just tells you a number, you'll still encounter occasionally in high school and in college, and maybe even in your job someday, a time where you have to actually read a scale and come up with a number to write down for yourself. It's really important that you're able to do that. It's one of your mastery quizzes, and by the end of this lesson, hopefully you feel confident that you can do that properly. So basically, all measuring is based on some device that has some kind of a scale on it. And a scale is basically just a number line, if you think about it. Oops, sorry about that. If you think about your basic number line, it might look something like this. 1, 2, 3, 4, 5, 6. So this is like a basic number line that you might have seen in one of your math classes when you were learning about number lines. And so when you look at a number line like this, what it's doing is it's representing these numbers with an image where the distance represents a certain amount. So like this amount of distance, what you see between 4 and 5 or between 3 and 4, that would represent 1 on this number line. And so I could ask the question, if I took and I put a dot right here halfway between 2 and 3, and it was exactly halfway between, well, then, and I asked you, well, what is the value of the position where that dot's at? Well, you would say to yourself, well, if this is 1 and this is 2, and then you get halfway to 3, you would know that that half is 0.5, and you would say, well, that's probably about 2.5. And when you do that, you're reading a number line. It's not always that easy. What if I just randomly threw a dot there? You have a judgment call to make. You have to say to yourself, well, is that 8/10ths of the way to 5? Is it 9/10? Is that 0.8, 8/10ths, or is it 0.9, 9/10ths of the way to 5? And since there are no marks in here, you kind of just have to use your best estimation. And so I'm going to say that that's probably 4.8. That's what I would estimate that at. But, and here's where kids get confused, not all number lines that you see on measuring devices are the same. So while this scale goes up by ones and there's no marks in between them, you might see a number line that looks more like this. It starts at, say, 0, and then maybe it goes 5, and then 10, and 15, and then 20, 30, etc. So now you look at this and you see that unlike the first number line that we looked at, where the space between the lines, the big lines, is 1, the space between the big lines here is 10. And that means that halfway between that space, if that space is 10, then halfway between would be 5. And so, if I had a blue dot exactly on one of these lines, it would be pretty easy to say what it was. But again, if you get one that's in between, you have to kind of estimate. So this space right here is worth 5. I could visually in my head try to cut it up into 5 little chunks. But I could also say to myself, well, I know that half of 5 is 2.5. And this one looks like it's just a little bit past halfway. So maybe that's 3. And so I could estimate this green dot right here. I could say, well, it's a little bit past half, and half would be 2.5. Half of 5 is 2.5. So maybe this value would be 23 for this green dot right here. So you kind of have to think about the number line and kind of reason through it and use your number sense to read these scales properly. And it takes a bit of practice. Let's just look at one more possible kind of scale that you might run into on like a number line. Let's say that it went by ones, but then it went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then that one was 2. And there were no marks in between those at all. And so now this one went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then that one was 3. Huh. So what this number line is doing for you is it's actually marking out tenths, right? And a tenth, I'm sure you guys all know this, but a tenth is 0.1. That's 1/10. So these little marks on here are all 1/10. So this would be 0.1 right here. This would be 0.2, 0.3, 0.4, and so this slightly larger mark, it's slightly larger because guess what? That's 0.5. It's halfway between those two, just like halfway was 0.5 up here. But on here, it's actually kind of marked out. So this makes reading your measurement a little bit easier because if you had something that came to right here, right on that little mark, then all you have to do is say, okay, it's 1.1, 2, 3, 4, 5, 6, 7, 8. So that would be 1.8 right there. But they don't always fall exactly on our little marks. So again, let's say we had one that was like right there. So, oh man, it looks like it's about halfway between those two little marks. Well, do you know what half of a tenth is? Half of a tenth is 5/100ths. This is the hundredths spot, and half of 1/10 is 5/100ths. So let's look at this for just a second. We've got 1, 2, and then we've got 0.123. So up to that point, we've got 2.3. We have 2 and 3/10, and then we're halfway to the next mark, so that's 5/100ths. So this little green mark right here that's halfway between those two little lines would be 2.35. So that's just kind of the basics on how to read a number line no matter what the scale looks like. Let's apply that to some real world stuff. Let's take a look at a meter stick. This is a section of meter stick. And let's look at the scale on this. Let's kind of look at it and pick it apart a little bit. Right here we see the number 40. Oops, sorry about that. We see the number 40. And then we have 41, 42, 43. So how many of these little lines are in between? Obviously the big lines are going up by 1. So how many of the little lines? And I know it's kind of hard to see. Let's count them out here. We've got 1, 2, 3, 4, 5, and you'll notice that one's a little bit bigger. 6, 7, 8, 9, 10. So there are 10 little lines between 40 and 41, which, if we look back up at our number line examples, it's like this one. Each little line is 1/10. Each little line is 1/10. So let's say we were measuring something, and what we were measuring came, I don't know, it came right here. Oh man, what would that be? Well, let's see. We'll look in there. We'll look really carefully at this. It's clearly at least 42. And then we've got 0.123. And it looks like it's between 0.3 and 0.4. So probably an accurate, as close as you're going to get, would be to say it's 42.123, and it's halfway between. And so for the next spot, since it's halfway between, we would put a 5. And those are millimeters. Whoops, I'm sorry. Those are centimeters on that meter stick. So that's how you would read that scale, 42.35 centimeters. in real life, those lines are pretty darn close together. So you kind of just have to use your best judgment your best judgment when you're trying to pick out the measurements for these things. Let's do one more. Let's say we had one that was right here, pretty much right on this line right here. All right. So we've got 43 is this line, 0.12 it looks like. So that would be 43.2. And since it's right on that line, you could even put a 0 on the end of it to say that it's right on that line, centimeters. 43.2 centimeters. So that's one example, a meter stick. Let's quickly look at two more examples, and we're going to do these a little bit more quickly. The next one we're going to look at is the triple beam balance. This one's a little bit more complicated. This is a triple beam balance, and we use it to measure mass. So this measures grams. And it's called triple beam because there are 1, 2, 3 beams that have scales on them. And most triple beam balances have a scale that measures grams, and then it measures, the middle one is usually the biggest one, which is kind of confusing sometimes. As you can see in this picture, it's measuring hundreds of grams. And then on the back one back here, it's actually a little bit smaller. It's measuring tens of grams. So the way a triple beam balance works is that you move these little sliders to the right until your triple beam balance gets perfectly lined up over here, and then you read what the sliders are pointing at. So let's say that when it was perfectly balanced, my sliders looked like this. Okay, what you would do is you would start with the biggest number, and you'd write that digit first. So our biggest number is 500. So you, in this case, would write 5. And then you go to your next smallest one, which in this case is this slider right here, and it says 40. So then you would write 4. So 540. And now it looks like on the ones slider, which is right here, it looks like we're in that little scale of having marked out tenths. So we've got 545. So that's, we can add that to our number, 545. Right? And then there's 1, 2 little lines, and each one of those is a tenth, so 0.2. And because it's right on that, we could actually put a 0 on the end of that if we wanted to. So 542.0 grams. 545.20 grams. Okay, the last example that I have for you it is, okay, so let's look at a graduated cylinder. They look like this. Those are graduated cylinders right here. And these measure, oops, sorry about that. These measure volume. Graduated cylinders measure volume. And the way that they do that is they have a scale on the side, and then you have to look at where the surface of the volume comes on the scale. Now we have to figure out the scale of this thing. So we have 50 here, and then this is 60 up here. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. So we go up 10, there are 10 lines, each line is 1, which means that at this longer middle line, that would be 55 on this scale. So when we measure with a graduated cylinder, we always measure the bottom of the curve of this fluid. So if you look at the bottom of this curve of this fluid, let's get a color that's going to show up here. It's about right here, the bottom of the curve. So what do we have? We've got 50, 1, 2, can't go 3 because that's over where the bottom of the curve is at, so 52 point, and it's well over halfway to that next line. So we're just going to say 52.7. And then this is a graduated cylinder, so it's measuring in milliliters. So that's just how you read number lines for making measurements. If you have any questions, as always, feel free to see me.